Data for Good today. We've got a really cool speaker that I'm quite excited to hear. He's graced Data for Good's presence before in some of our other chapters, but if you read a bit about his bio in our meetup, you're probably excited too to hear Cam talk. So here's what we're going to do. We're going to talk about a little bit about Data for Good. For those of you that aren't familiar with us, there's a lot of repeat visitors to our meetup, so thanks for coming out. We'll talk about the DataVis challenge that's launching today. Arnav is going to share that with us, and then we'll get into what I'm setting the bar as a sensational speaker. So that's how we'll rock. If you want to stay in touch with Data for Good, you want to volunteer, or you have a project you want us to take a look at, like you're a charity or a nonprofit, or you just want to stay in the loop, you can go to regina.dataforgood.ca, and there are these forms on the site. So just scroll down the site and click on one of these forms, and no matter which form you sign up to, you'll stay in the loop. And obviously, being a part of this meetup will keep you in the loop as well. So let's just talk a little bit about what Data for Good is and what our purpose is. Our purpose is to build data literacy and socially focused organizations. And Data for Good does this on a national level and on a quite localized level. So Data for Good is an organization that has chapters in about 10 cities across Canada. And each chapter is run somewhat independently. And really, essentially what we do is free data work for charities and nonprofits. And so that's the first part of our mission. Second part of our mission is to contribute positively to the data community here in Saskatchewan. And so this is specifically talking about Data for Good Regina and Saskatoon. And we do that in numerous ways, which I'll talk about in a second here. We've got Data for Good has a whole bunch of people that make it operate, or that help it operate. One is we have these chapter leads. And so myself, Scott Wells, Marina, and Josh are together, the four of us kind of captain the Data for Good ship here. But, really this is a community-based organization, and it's for the community. So it's the community that really drives it. But, people like us make sure the meetups happen and that we get projects in the door and things like that. So we're just stewards of the group. We also have Cody Rogers, who's our community lead, who helps organize these meetups. These things wouldn't happen without him, and we wouldn't get great speakers like Cam without him. Arnav, he runs our DataVis challenge, and he's going to be talking here in a second. And then we have Heidi, who, if you're on our email list, you're getting emails from her. She's our communications person. And essentially on the right-hand side here, these are the areas that we operate in. We've got these meetups and light projects, major projects, and DataVis challenges. And so first thing we're going to talk about is we'll go into those four areas in a slight bit of detail here in a slight bit of detail. First one we'll go into is DataVis challenges. And for that, we have Mr. Arnav.
Awesome. Thanks, Kevin. Yeah, so super excited to launch the new DataVis challenge for 2022. Keeping in line with the talk for today, we'll be looking at a data set from Stats Canada. We'll be looking at the Canadian Survey on Business Conditions, or CSBC. More on that in a couple of slides, but Kevin, if you can skip to the next one. So what is a visualization challenge? So essentially, we're going to be taking a data set, creating a visual out of it in order to tell a story. And by doing this, you can show off your data skills and develop those data skills by building a portfolio. You'll also have the opportunity of presenting your data visualization report to the wider audience, and have the opportunity of working with like-minded data people within Saskatchewan. Next slide, please. Yeah, so what makes a good visualization? The first thing is definitely keeping it simple. So the audience should grasp the message at a glance. It should tell a story. It should be compelling and should have a narrative. And then, of course, you have to be creative. So the visualization should be appealing. If you go to the next slide, there are a couple of interesting data visualization dashboards that are up on Tableau. So the first one actually shows the contributions to the various songs on the Beatles records by songwriters. So you can kind of see each of the records are there on the top, and you can see the contribution by Lennon, McCartney, Harrison, Ringo, combination of the two, or other at the bottom. And each star, the white stars in the middle of those layers, are essentially songs that charted in the top 50. So you can see which writer contributed the most to each record, and also how their contributions ended up reaching the top 50 on the charts. The next slide shows a visualization that's pretty neat as well. So this is essentially showing the impact of COVID on box office numbers and movie theaters. So as you can imagine, once the pandemic started in March of 2020, the heat map on the right kind of drops off significantly around mid-March, as the COVID pandemic and lockdown started being implemented. Some other interesting things. So if 2019 is kind of the last representative year, I guess you can see there are some months or parts of months that are really popular in terms of box office performances. So that would be end of December around the Christmas holidays, and then also July 4th in the US, and towards the end of July as well, as people are taking part of summer holidays and things like that. So yeah, next slide, Kevin. So the rules for the DataVis challenge is we'll be basing our data set from the Canadian survey on business conditions. You're allowed to add to that via other data sets if you choose. That's not necessary, but definitely that's something you can do. You're allowed to use any BI or visualization tool, so anything from Power BI, Tableau, Excel, PowerPoint, any tool that you're comfortable with. The final submission will be a single page PDF, and you can work on this individually or as part of a team. And yeah, the next slide. So basically what the CSBC is it's basically a quarterly pulse check on business conditions, sentiment, and expectations that Statistics Canada has just recently rolled out for Q1. And this essentially helps policymakers and governments and businesses identify strategies to help support communities and organizations. It is a very wide-ranging data set, so we definitely recommend that you focus your visualization on a specific topic. So some examples can be the impact of COVID-19 on businesses, what the expectation, condition, and obstacles are for rural businesses as opposed to urban businesses. Similarly, what the expectation, conditions, and obstacles are for small businesses as compared to larger businesses. And then finally, you can focus in on businesses owned by diversity groups. So that includes women, First Nations, Métis, visible minority, LGBTQ, or persons with disability. Yeah, next slide, Kevin. So just in summary, once you're ready to register, you can definitely just send an email to Regina at dataforgood.ca to enter into that contest. Please let us know if you would like to work solo or you want to be part of a team, and we can help place you on a team. And again, if you want to be part of a team, you can also just mention what your skill and comfort levels are, so that can be appropriately matched up with other people. And then the deadline for the contest is June 21, 2022. So please email your submissions by midnight, and then you'll have the opportunity of presenting your submission at the June 2022 Data for Good meetup, which is scheduled for the last Tuesday of the month on June 28th. And yeah, so there's usually a prize as well, details to be announced, but definitely there'll be a prize as well for the top DataVis report.
Arnav, I am disappointed you're not on camera showing your loot from the last DataVis challenge. Arnav won the last DataVis challenge, and he won himself a mighty trophy, and that I'm sure he's drinking all kind of beverages out of
Yeah,
So
it's just in the next room. So maybe by the end of the call, I'll go pick it up and show it off.
yeah, yeah, right on. Yeah. So yeah, Arnav is the winner of our last data challenge, and we had about 10 teams last time, individuals and groups work together on the last challenge. So right on. Thanks for that, Arnav. Uh, oh, last thing here, I think, is DataVis examples.
Yep. Yeah, exactly. So yeah, if you're interested in learning more, just a few links there as well, just to get the ideas flowing.
These slides will be posted on our SlideShare account, which is publicly available. So feel free to check those out after the meetup. Cool. So I'll just breeze through a couple of last things. If you're new to Data for Good, in being of service to the community, one of the things we do is we run these meetups that you're currently attending every second or every last Tuesday of the month. And so prior to COVID, my ask would be if you had a location we could speak at, we'd always be looking for venues. But if you want to speak at Data for Good, let us know. And we've had a whole bunch of people. We've had charities speak. We've had professional football teams, riders speak. We've had ag companies speak. And so, anybody who wants to talk about data or talk about their challenges with data is welcome to submit an application to speak at one of our meetups. We also do projects. And Scott, I don't know if you're online, if you want to chat, but we work with a variety of projects from small small projects where people are just using a single spreadsheet and they just need to learn how to dashboard, or they need to learn how to dashboard data. Or we work with organizations like the Regina Food Bank, and where we have people like Sean Mill on the call today, who did some really awesome geospatial work. And they're trying to solve business problems, like, is there food bank in a location in our city that is the most useful to the people? So and they have a little bit more sophisticated data sets. So we really work with all organizations. There is no criteria other than a willingness to get better to use data. Some of our current projects right now is we've got a cost of living project happening right now. There's about a team of 10 volunteers who are essentially trying to create increased frequency and more of a streamlined way to get data by geographic regions in the province. And so the goal is to produce data that can be publicly available for different regions to understand various cost of living factors for those specific regions. So we had our kickoff last week, and about 10 volunteers jumped on board. And so that project is getting underway. It's a joint effort between Saskatchewan and Regina. And then currently Data for Good here in Regina is working with the city. Data for Good has been invited to some various summits, food summit, housing summit, problematic substance use summit, and really to help see if we can help sectors use data better to help solve some of our biggest issues facing living abilities here in Regina. Okay, last thing is if you want to get a hold of us, here's all our various ways. You can tweet at us, or if you're likely part of the meetup, if you're here, we have our website. Most of our slides are on our SlideShare account. If you want to be part of our Slack channel, just email us at regina@dataforgood.ca, and we have an Instagram account that we update once a year. So we'll see when that's going to happen this year. So on to the good stuff. We have Cam Rayner with us tonight, and I won't speak too much about it, Cam, but I did a little PI work on you, and he's got a company called RA2, which does essentially they're a public engagement and campaign consultancy, and they do a lot of cool research around public opinion, NLP, machine learning. They also do campaign strategy. They look at public engagement. So they really kind of are trying to understand what we're thinking, and we're really pumped to have Cam here to talk about survey data. So with that, Cam, the show is yours.
Awesome. Thank you, Kevin. I guess I'll just try to get my screen shared here. Bear with me for 1 second. This might be a recurring theme throughout this presentation. We'll be struggling with screen sharing. I'll switch back and forth from a few things as we go. Awesome. Great. So as Kevin mentioned, I run a company in Calgary called RA2, and we work on largely political campaigns and then public engagement efforts. Some of our clients that we've worked with in the past are at the bottom. We also do a fair amount of work with the city of Calgary itself, so like peer government work. Basically, we use data to understand the stakeholders of an organization. And for most of the organizations we work with, a big stakeholder that they have is the public, which lends itself to public opinion research. So for today, I'm going to talk through a little bit about how you can use survey data as part of your data analysis process. Survey data, there's a lot you can do with it, but it can quite quickly require special analysis techniques. And it also gets a bit of a bad rep with things like political polling, especially, taking a beating when they inevitably get the election result wrong pretty much every time, it seems. And then I guess RA2 also does a fair bit of like social network analysis and NLP machine learning work. So if you're ever interested in just chatting about that, my contact information will be at the end of the show, at the end of the slide deck. But also survey research can be a really good underpinning for that type of stuff as well. So if you need a data set, oftentimes it's not just available for you, you have to go ahead and gather it. And one of the ways to gather that can be these surveys. So to start, I guess it's useful to think about what we're trying to do when we're using survey data. So typically, unless you're surveying every single person in a group and you have a census, what you're trying to do is learn something about the characteristics of a population. For example, we would have done polling in the last municipal elections in Calgary, where we're trying to understand something about every person that lives in Calgary from a small group of those people that you can survey, so a sample. So as you can sort of see in this diagram here, you're sampling some people, and then you're doing some inference about what the whole population is that you took that sample from. So this is done well. You can do this with a high degree of accuracy. If it's not done well, you can do it with a low degree of accuracy, so to speak. So before we get started, like thinking about where are some of the ways that if you're doing a survey where you can get error from. Actually, maybe to go back, I should say this doesn't just apply to things with a population like the public. It also includes, like, if you're doing a survey of people in your organization and you want to say something about all of your customers or all of your employees, and you know that not every single one of them is going to respond to that survey. The same idea is that we think about a lot when we're thinking about trying to estimate like the opinions and beliefs of the entire population or of the public apply to the same issues come up when you're doing it with a different population that you might know a little bit more about. So one thing that I think surprises a lot of people, at least it surprised me when I first learned about it, is where survey error comes from. So the most common reported survey error that you've probably heard is something like news announcement, Joe Biden is up ahead of Trump by 3 percentage points, 19 times out of 20, a polling result like that. And that is actually the margin of random sampling error that's being reported. So that's the statistics that you'd be familiar with from as far as, as early as grade 12 statistics, or certainly like a first or second year statistics course, you'd cover this in depth. And that's the amount of error that you have just because of the size of the sample that you have versus the size of the population that you're trying to estimate. when we get into survey design, there's actually a lot of other ways that you can introduce error into the process. So there's sampling error, which is, do you have the right people that are being surveyed? Do you have enough people there? Did you ask questions that measure the things that you think the questions measure? Sorry, that would be a non-sampling error. There's non-sampling error, like people not responding, these sort of issues. There's a lot of other places where you get sampling, where you get error in the survey that aren't just how many people responded or if the right people responded to the survey or not. And essentially you end up with this like mean squared error, this total survey error framework. A lot of the times it's pretty hard to estimate some of these other things. Like we don't have a clear statistics, like it doesn't fit a bell curve. So it's more of a discussion to have with your team. So there's some more practical considerations. So something I want to highlight. So I have a data set that I've shared in a Git repository with the group. And this data set was gathered using an online panel. So it was an online sample. Specifically, I think it was through Donata. So there's a lot of different places that you can get survey data. And if you're trying to do public opinion research, common ones are online panels or phone interviews. And both of these have some known considerations that you're taking into effect. Other samples you could have would be a sample like if you send an email out to everyone on your mailing list and you're asking them all to take a survey. Essentially, you have what's called a probability sample versus a non-probability sample. And the basic idea is a probability sample, every single person who is in your population that you want to study has some chance of being able to complete the survey. So if I randomly phone every phone number in like Regina at random, and everyone could have completed the survey, then I would have satisfied that I have a probability sample. If I go to a list of people that I just happen to have their emails for, and I know that they all live in the city, and I email them my survey and ask them to complete it, then I'd have a non-probability sample because some people didn't have a chance to complete that survey that were in my population that I wanted to estimate about. In modern political polling, it's really common to use non-probability samples, mostly because who answers their phone anymore for a survey? So it's become really expensive to get people on the phone. And it's costly, basically. So you're weighing the cost of having a convenient list, like the list of people that you can email, versus the really like statistically rigorous and correct way, at least traditionally correct way of being able to include everyone. But it's something that you should really keep in mind anytime that you're given survey data is like, how did they collect this data? Where did it come from, and who was included and who wouldn't be included? So with these online panels, they'll usually tell you things about who's in them, how they recruited the people into these panels, who you're paying to access if you go to a provider like this. But it may not be the best option. It may be that you have to come up with a different way of accessing people and getting them to take your survey. So these are some of the other issues that you get as soon as you actually put out your survey. The first one is like you get nonsense or even like fraudulent responses. This one's especially important if you have an incentive. So if you're offering people like a chance to enter a draw, or sometimes like even had the luxury of just giving everyone like money if they complete your survey, and that makes it a lot easier to get people to complete your survey. And then you end up with, you could have people that just want the incentive. So that one's common. There's a concept called satisficing. This is pretty widespread, which is people take mental shortcuts. So this is especially true if your question's really complicated and hard to come up with an answer for. People will substitute in an alternate, easier one. There's a lot of behavioral economics about this. People just aren't paying attention and going through too quickly. So because of that, it's typical to implement a range of quality control checks. And this is one thing I would really encourage you to try if you haven't done it already, anytime that you're working with a survey, is to incorporate some sort of quality check. And the ones that work really well are almost embarrassingly simple. So there's an example here of an image, like this image is a screenshot from a survey that RA2 ran recently. And this was a set of questions, and there's one that just says, to ensure data quality, please select, is it completely true for this option? Especially with an incentivized survey, this can screen out like 20% of your responses as being people that weren't paying attention. It can be really high. So it's hard to know if someone was paying attention, but these sorts of things are clear cut. Some people will do more complicated ones, like they'll have a kind of a gotcha, like you answered that. It's almost like they're like cross-examining their respondent. It's like, you answered that you were like male, but then you said that like in your shopping cart you have all of these like traditionally female products. I think that's kind of gone out of style, but that was like a typical approach that people would take, and they would use that as an indication that the response might not be good. But then, you know, the big thing too is just keeping things very short. So short surveys. The longer your survey goes, the more it falls apart. One number that you can keep in, like less than 5 questions is ideal, and you start to see it drop off after about 5 questions. That's one that we often consider. And then another one is about 20 minutes. And there's a lot of research on this as to when response quality starts to deteriorate. And 20 minutes is a pretty big drop. So if your survey is longer than 20 minutes, you should be pretty concerned about the quality of the responses after that. And if you're interested in the trap questions more, there's, I think, Kevin, correct me if I'm wrong, where these slides should be available to everyone. So if you want to look at those, there's people that have done experiments on what types of trap questions and things work really well.
Yep, that's cool.
So the other problem that you often end up with survey data is missing data. And this is especially true if there's like a prefer not to say, or someone declines to answer or doesn't know for some reason about some question. And there's different types of missing data. The ideal scenario is that your data is missing completely at random. And this basically applies for everything to do with surveys. So if you imagine that you're interested in estimating how many people care about a specific issue in your area, and some people decide not to respond. Your ideal scenario is that it's just a random assortment of people that don't respond, and it's not, for example, that all the people that disagree with that or don't care about the issue decide to respond, because then you have a bias in your estimator. For the most part, everything assumes that this missing completely at random is true. Like it's almost an assumption in every model that you'll look at in survey statistics, but it's important to keep in mind because it's sometimes hard to make sure that that is true. Yeah, so then there's missing not at random, where there's a pattern to it. Some of the things too are, one common one that's worth bringing up is social desirability bias. And this one's especially true if you're dealing with populations that are vulnerable in any way. So an example is like RA2 is doing work for the city of Calgary around mental health and addiction. So a lot of questions that have to do with mental health and addictions are sensitive. People might not want to talk about those things, and it's not necessarily a good idea to put those on a survey, partly just for their own privacy, but also because, you know, how many people, like, you know, show of hands, if you are like addicted to a hard drug, you know, it's not likely that very many people are going to respond to that. And then there's missing at random, where there's a relationship between there's only a relationship between missingness and the value that you're measuring. So that one's a sort of a little bit more nuanced, but it comes up occasionally. I'll skim over this, but basically when you have missing data, you can either exclude those responses or you can do something called imputation. And that's what I'll show today. Is I'll show how to deal with missing data, like how to calibrate a survey data set so that you can use your standard tools or whatever tools you prefer on it. There's tons of ways to do this. Basically, when you have missing data, you can put in a different value for it so that you don't have to exclude that person's response. So say you're missing someone's age, you could either exclude that person's response because you don't have their age, so then you can't do any sort of comparisons by age, and that it might throw off your analysis. Or if you're only missing a few people, you might say, oh, I'll just make everyone who's missing, I'll make them the average age of the whole entire group. And that's valid. That's an approach. And with sort of, I call it like modern survey analysis, there's more complicated methods, particularly this one called multivariate imputation by chained equations, which sounds complicated, and honestly it is quite complicated, but it's really, really easy to use with modern programming. It's sort of trivial to implement it. And basically what this does is you estimate all of the missing data using all the rest of the data that you have. So you fill it in using as much additional information you have as possible. So if you're missing age, you could estimate the age of the respondent using every other piece of data from that survey so that you can still use their response. And you know that age has been estimated, but it means that you can still report like average age by voting intention, or average age by like willingness to get vaccinated, these sorts of things, because you've managed to do that imputation. And it tends to lower your margin of error when compared to just removing those people from the survey completely. There's tons of documentation. The second link down here is the full academic paper that describes this method, and it goes into it, and a huge amount of detail if you really want to get into it. But like, highly recommend checking this out if you're using survey data. So yeah, I guess I'll switch over to R now. I know probably not everyone is necessarily like an R language programmer. It's really helpful for some of the survey tools. A lot of the work that we do at RA2 is either in R or Python, and survey analysis tends to lean heavily towards R, just given the sort of nature of where the tools are and different packages that you can use. But hopefully this will be able to follow along. And for those of you that want to try this out for yourself, I've shared a GitHub repository with the code from today, and a data set that you can play with. So here's that. Okay, so should be looking at my screen now. Good. Yeah, so this is the script that I've shared with everyone, and I'll walk you through the steps here and just talk you sort of through what happens. And this is a very standard data weighting framework. So we'll get ahead here. So all I'm doing here is just setting up my my R environment. You'd have to install these packages if you didn't have them installed already. I assume that if you have used R before, you know how to install packages, but and then I've imported this data file. So this is in an R data format, and the data's already been cleaned. I uploaded it as a CSV file as well, in case anyone wants to just look at what's actually in this data set. But if you look at the bottom of my screen here, you can kind of see we're looking at a survey. It has the respondent's ID here. it has their voting intention, it has their willingness to get a COVID vaccine, and then it has a bunch of variables, like their whether or not they feel financially secure, different responses around their sense of conflict and sort of tendency toward and feelings around like authoritarian language, which is a common political psychographic breakdown. And then we have a bunch of demographics like age, gender, education, income, whether or not they have children, home ownership, their region, and whether or not their postal code is in a rural area. And then we have a key here, which is mostly for census data, which we'll get to later. But this is basically the starting of your postal code, what area of Canada does that correspond to. And then we have some census data, and this is also included in that Git repository, but it's taken straight from the 2016 census, although we have 2021 census data now, which is fantastic. But just for this presentation, this was before the 2021 census. And then we have this package mice, which is how you do imputation. So if we take a look at our data, we can take a look here, and we can see here's our data set again. So this is there were about just shy of 1,600 people that completed this survey, and we have some things about them, know some things about them. And then here I've just knocked out a bunch of ages for some of these respondents so that we'd have some missingness in the age, because we actually had the age for all of them. So if we look here, we can see that like 0.1% we were missing gender data for, and then yeah, none we were there. Sorry, forgot to run that. Would help. And then we have about like 1% that we're missing age data for now because we've knocked some of those out. So these are good numbers because we're not imputing more than about 5% of the responses, which is considered like a good rule of thumb for how many of your responses can be like synthetically generated as part of your data set. Anything beyond that, and you sort of start to ask questions about whether or not it's really valid for you to be generating those attributes. So then once you've looked at this, it's really simple. So we have this subset of the variables that we want to use. And I guess what's worth mentioning here is that the algorithm is going to use every variable in this data frame or this table to try to impute the missing ones. So if I wanted it to not use these conflict variables, I'd have to drop those columns out before I run the next step. So then as we go down here, and this is how simple it is. So with like a programming language like R, you get a function called mice, and this mice function has a whole bunch of options, like a ton of options, but it also has really sensible defaults. So if you don't change things, it will usually do a good job. And I'll talk about that a little bit more in a second. But we run this, and this is running right now, and you can see it just went through and did 5 iterations of 5 imputations for each of them. And just like that, we now have imputed values using sort of best-in-class algorithm for it. If we take a look at this, it creates this object called a MIDS data set. And if we look here, it will show us that it used different techniques for each of the different values that had missing data. So in all these variables here that are highlighted where there's nothing, it didn't need to use any technique because it already had information for it. But for gender and for age, it used logistic regression to choose gender because it was only using 2 gender categories, male or female. Most people use more inclusive gender language than that. Oftentimes now it'll be like one or not the other, depending. And then for age, it's using ordered logistic regression, and it just takes care of that for you. So it estimated, that's the method it used. If you read all the documentation for mice and find that you want to use a different one, there are ways to specify that in the when you call the function. So yeah, from there, basically you run this complete function here. You give back your IDs, and then here now we have a data set where there's no missing age, there's no missing gender data whatsoever in that data set. So if we look here, we can see, yeah, here you can see there is this missing age category for this respondent here. That was number 10. And then if we look at the imputed one, then now it's estimated that that person is 55 plus. So no problem anymore. We can now use that response anywhere. And then you can sort of see a summary of the data, and you can see that there's no missing values in here anymore. So that's the first thing that you usually run into with survey data, is that there's missing data, and it's how do you handle this missing data? And this is about one of the more complicated problems that you'll run into, and hopefully with that, that's something that you would be able to deal with. Now, if you didn't want to do that method and that was too complicated, two other methods that I think are just worth mentioning here that you could easily do in Excel or Tableau would be just to take the average. So if you are missing age for some people and you just take the average age and give them the average age, that can work. Another one is to take the most common. So if you had categories and you looked at which one occurs the most often and you use that for your missing data, that's also a sort of an accepted way of doing imputation of your missing data. So then the second thing that we have to do, now that we've fixed all of our missing data, the other thing we have to do is we have to make sure that our sample matches with our population. So if you remember from way back here, when you're thinking about this sample matching and doing inference about the population, this only works if this sample kind of looks like the population. So for example, if you know that your population is about half male and half female, but then you look at your survey responses and you see that 70% of your survey responses are male and only 30% of them are female, then you kind of know that you might have a problem with making that leap back from that sample to the population. And this goes for anything. Like if you surveyed your organization and you knew that it was half salespeople and half engineers, and you found out that only your salespeople responded, then you'd have a problem with doing inference on what, for example, how satisfied like everyone in the organization is with their job. So in cases where this isn't a huge issue, there's something you can do where it's called weighting, and basically what that is you assign a weight to every response so that in the end it adds up to the population parameters that you know about, that you know it needs to match. So in that case, you might say that, well, when I do averages, I'll just take my female responses and I'll give them a higher weight so that it balances out with, because I know that I don't have enough of them in my sample, so that it balances out and then I actually have accurate estimates. This is usually done in political polling. Like I can't actually think of anyone who wouldn't be doing that. So almost always you do some sort of adjustment to adjust for the people that don't respond, and usually it's young people that just don't respond to surveys. So typically you're sort of, if someone is 25 years old, they're probably getting counted for like 3 times as much as someone who's older in the survey response, just because they don't tend to answer surveys. So the idea being that if you think that this, yeah, if you don't have enough of one group, you just do a weighted average instead of a simple average. So coming up with so like, how do you come up with this weight? So basically the most common way to do is this process called raking. Basically, that is you iteratively adjust a weight for every response until your entire population matches your sample margins. And in R, this is done using this function called rake from the survey package, or this ANES rake, which is actually more of a gold standard, but I will just show it using the survey package. And this greatly increases the accuracy of your survey without having to collect more responses. So I've put together some example code for that as well, which again is freely shared, so you're welcome to try this out on your own. And I think this will make a little bit more sense if I show you it. So if we go back here, can we see this? Is the right screen again? So basically what we're going to do here is I want to make sure that my respondents are similar to what I know from the census the population should look like. So if you look here, we have we have 740 male respondents, 835 female respondents, which is actually pretty good. For age, we have 330 18 to 34-year-olds. We have 596 35 to 54-year-olds, and we have 649 55-year-old plus people. So this looks like a problem on first hand, like there's not twice as many people that are 55 plus compared to people 18 to 34 in Canada. So our survey results might be pretty biased. The other thing is, if you look at education here, there's about 400 people with a high school education or less in the survey, about 100 with trades, 300 with college, in the Canadian sense of the word college. And then there's almost 600 with a bachelor's degree and almost 200 with an advanced degree, like a degree in medicine or a master's degree. So as you can imagine, there actually aren't like almost twice as many people that have university degrees as people with high school, who have a high school level education in Canada. It's just that those people are more likely to take surveys. So again, we kind of have a problem where if we're trying to understand what Canadians think, what we're actually learning is what Canadians with advanced education think. So we need to do some adjustment here to make sure that these things line up. And where we go to that is, this is where something like good census data that Canada has goes a long way. And this is some data transformation that's going to, you're welcome, I won't go into here, but that's going to take a look at our census. Got some warnings, those are all fine. And basically we can use some of the census data to come up with what we should have. So if we had taken a perfectly balanced sample and we had exactly the same number of male and female respondents compared to the real population, we would expect to have 773 male respondents and 802 female respondents. And if you remember from before, we didn't have that. We had 740 male versus 335 female respondents. So you can see that we were off by just a little bit. So we're going to correct for that, and we'll do that for each of the different things here. So here we can see these are the frequencies that we want for Atlantic, Ontario, Prairies, and BC. Oh, I did something wrong here. Okay, we might just have to wait by gender. Okay, and then we have rural there. So if we look here, we can see this is just some checks in R. And then we will look at here. So this is this rake function. So essentially what we're doing here is we're telling it that I want my sample to match, and I'll just do some changes here. We'll just do this by age and gender. So we're saying here, I want the age and the gender in my survey to match the age and the gender in my population. So if we run this function here, oh, it did not like something that I did here. We'll just do age. Yeah, so if we just do this by gender, you'll see it's applied some weight. So it's made an adjustment where some people's response is going to be worth sort of 0.96 of a response versus 1.04 of a response. So it's added these calibration things for it. Yeah, sorry about that with the weights there. I'll have to look at what I did there. I think I reduced the file size to upload it to GitHub. That's what happened. So then if we take a look, we can see that there's here that it has these weights and they actually look really nicely normally, where basically people are either male or female. So it's either applied one of these two weights to them, and the reason it's bimodal there is because people were either in the male or female category. So we can take a look and see this calibration of 1.05 or 0.96. That's really good. Generally, after you do this for a whole bunch of different groups, you can end up with really high or really small weights. So one of the problems with polling can be that you actually have like one person that counts for like 15 people's responses. And if that person has a weird opinion, then it looks like the whole population has a weird opinion. So one of the things that pollsters can do, and that you can do in any sort of survey data analysis you're looking at, is you can look at these mins and maxes. And a good rule is to make sure that none of them are bigger than about 3.3 or smaller than about 0.03, depending on how big your sample size is. Because, you know, if you imagine if you're doing this by like ethnicity, age, education, region, and gender, and like you're really missing like, you know, female, like non-white, high school education, living in the prairies, and then like that one person that matches that shows up, they can end up having like a huge weight, like 15 or 16 or something like that. And then when you do your weighted averages, they end up having a huge impact on it. So then, yeah, so then using, just make sure I have the right thing. So then this, but what this is giving you is it gives you, if you look here, it giving you the weight for every single respondent. Here, this is trimming the weights. So with R, you have this command here that will trim the weights for you. So that upper 3.3 and that lower 0.3, and that will stop that sort of skewing of your data. So if you do these steps, if you do your raking by setting what your population should be, and then you trim it, you'll essentially have data that you can export back into any sort of tool that you like to work with. Maybe that is R and you just want to keep working with it in R. Maybe it's Python, maybe it's Excel, maybe it's Power BI. Whatever that is, and you'll have these weights that now you can use to calculate like weighted averages, weighted counts, all of these sorts of things. Oh. Take that. So then here we can get, here's our survey, and now we have, for each of these respondents, you can see it's applied. We have this weight category, and for those weight categories, that lets us do something like calculate how many people there are by age now with this weighted adjustment. So yeah, this will now calculate survey statistics correctly for you. And so this is where the population data was pulled from Statistics Canada there. So that's the source for that. Yeah, that's my overview on survey statistics. So at this point, if there's any questions, I'd be happy to sort of discuss any of this or dig into whatever you'd like to dig into.
Right on, man. That was awesome. Thanks so much for that. Questions? Oh, we're never really a shy bunch over here, so I'll start off. In general, when it comes to survey data, is there any kind of body that governs accuracy of data that is used for the public?
It's a really good question. Sort of is the answer. Like, there's not a professional body that you have to be a member of per se. And there's definitely a lot of cases of people putting out really bad data from surveys. There's the American Association for Public Opinion Research. It's called APOR. They have membership in like a standard of ethics that public opinion companies should adhere to, and they're a really good resource for a lot of things. And they have an accreditation for public opinion firms that do follow their guidelines and practices around transparency.
Right on.
It's an ongoing issue because there's always, well, every time there's a bad poll, it kind of besmirches the whole entire industry in a big way.
Yeah.
Follow up on that question. So is there a way to, as we're looking through the media or otherwise, to see that that poll was done appropriately, that it follows the accreditation steps or otherwise? Like, is there a way to spot the bad surveys really easily?
There's a few things you can look for. One is just to look at the company. So if you're looking at something from the big ones in Canada would be like Ipsos, Leger. They're going to follow best practices almost to a fault. Like, it'll be like the best practices to a T. And typically they're going to release a bit of information, at least about their methodology and where they got their sample from and things like that. Another thing is you can look at the sample size and where it came from. And then you can think about what bias the way that they got that sample would probably have. So if you see someone did a mode would be like IVR, which is basically a robocall. You think who's going to answer that? It's mostly people with landlines, so you're going to get kind of older people. If you look at one that's like advertising based on YouTube or something like that, then it's probably younger people that are watching YouTube. So those would be the two things, would be to take a look at how many people, like what their actual release numbers are, like their sample and their methodology in it, and just think about who would be overrepresented and who would be underrepresented. And the second one is to look at the firm and see if they're a member of like a professional organization, they have a good track record, etc.
There's a question in the chat there that I think you might have answered, which is, do the organization that conducts the survey need a research ethics approval?
No, interestingly. So we do, like my company does go through that sometimes, let's say, because it's expensive and it's not required. But yeah, generally speaking, it's not a mandatory thing for people to run surveys. And if you think about that, it does kind of make sense. I think there's exceptions, like if you're doing medical research, and there's like legal requirements around that. If you're publishing public opinion research in a national election period or a provincial election period, like read your Elections Act for sure. There's restrictions around that and what constitutes legitimate, like sort of and not misleading content. But there's not like you would have in a university where you're required to go through like research ethics board approval. And some of that makes sense, right? Because if you're just sending like a survey out to your friends, something like that, or you say like, Data for Good, even just wanted to know like who wants to have things on Wednesdays versus Saturdays, then it would be really onerous if you said you had to go through Research Ethics Board, and there's a whole obviously scale of things between that and something that's being published for political purposes.
Cool, man. I don't want to hog the mic, which can happen, but any other questions?
I have a question. So it's first of all, thanks for the presentation, awesome analysis. The question is not related to analysis, but let's say if you hire a company which would survey for you and do some follow-up analysis, let's say customer segmentation, etc. So in one instance, what happened was we hired someone, analysis, segmentation was done, but then company was not willing or bit reluctant in providing us details such as which algorithm was used, what were those coefficient meant, what parameter and how they were tuned, etc. Those details, right? Is that a normal practice, or it's an odd one out case?
It varies depending on the company, but I would think, generally speaking, and this is just a personal opinion, but they should give you that information. I guess we definitely lean on the side of open data, be transparent about what you're doing, like have a conversation with the community. So those are definitely fair questions, I think, to be asking, and people should be able to defend how they've analyzed their data and what assumptions they've made.
So in a way, it's a fair game if they say no. Sorry, yeah.
Oh, go ahead.
I think I cut someone. Okay, so is it a fair game if they say no? It's kind of acceptable response. Most
of the companies that I'm familiar with would tell you at least what analysis techniques they've used. It's somewhat common practice to not hand over the individual responses to the survey, depending on what the contract is, for privacy reasons, because there's concerns that if you gave over the individual responses, someone might be able to figure out who a person was, and that might be unethical, depending on how that information was used, and if there was an assumption of trust between the person administering the survey and the person responding. That would be the main place where they think there would be a really legitimate grounds for a company to say, no, I'm not going to hand that over. If you ask a company, how did you come up with this estimate? I think that's a very fair question to be asking, and something that more people should be asking, because hopefully one of the things that you can see is that there actually are a lot of judgment calls that you have to make. You have to decide whether or not this is a good enough sample, or if this way of estimating is valid, and there's not you can't just open up a textbook and here it is in the appendix, it says you should do this one every single time. There's these things are debated, and if you're making decisions based on that information, it's helpful to understand what assumptions went into that, and what risks there might be, or what things might, if an assumption was wrong, what the implications of that would be.
In our case, we provide the data. There was no PI issue. It's just that we felt like the surveyor was a bit reluctant in providing us details related to model they built, and we felt a bit. I didn't personally liked it. But thanks for the detail. Good to know.
I think fair questions for sure.
Thank
you. You're able to wait like this in Python or SQL? Yeah, you can. I haven't ever seen it in SQL. Like, that would be quite the SQL sequence if you could do that. If you manage to do that, please let me know. But certainly in Python, the thing you'd want to Google is survey raking or survey weighting in Python, and there's those packages are new. Generally speaking, survey data has been the domain of like academics, and they like to write in R. So there's more in R, but the pieces, the weighting that I showed with raking, that's doable in Python. I think there's a pandas survey package now. You should look for that.
All right, thank you. I'm pretty new into it, so still trying to learn everything.
Yeah, if you weight your data, you'll be a step ahead of most, like the most common survey analysis. Like you'll avoid almost most of the traps just by doing that, and even the thinking that you have to go through in order to make those weights, like to decide what the population is and what the survey responses should have matched, will probably get rid of most of the big errors that could derail you. But yeah, there's an emerging survey analysis in Python community.
Okay, awesome. Yeah, I hadn't heard about that. It makes sense that it would be in there though.
Right on. You've got your details up there. If anybody wants to get a hold of you, Cam. If anybody wants to, if there's anybody who's kind of learning how to get into survey data, and they want to kind of explore how to do analysis and such, do you have any resources?
APOR is really good. So it's AAPOR. Let's put that in the chat. They have good resources, especially around like the professional conduct and ethics questions, which came up a little bit. I would definitely take a look at what they're doing, and then there's good tutorials. That DataCamp has a survey analysis one module that's quite good, that will cover some of this stuff. So those would be the two that I would take a look at.
Right on. Well, thanks for sharing the time. We really appreciate it. If you want to ask Cam any more questions, his details are live there. And I think, Cam, I think I heard you say that you're open to share this presentation. So we'll throw this up on this meetup on our YouTube channel if you want to review any of the smart stuff that Cam was talking about today. Otherwise, we'll see you folks on our next meetup in the next last Tuesday of the next month. Thanks again, Cam, for hanging out.
Thank you.
All right. See ya. Mr. Wells, what do you think? Or are you not really here?
No, I'm here now. You want to stop recording?
Oh, yeah.